In 2005, the U.S. House of Representatives Conference Report 108-792 stated that further testing of wireless technologies, including vehicle immobilization technologies, is necessary. In support of this and the Federal Motor Carrier Safety Administration's goal to improve safety, security, and efficiency, the Oak Ridge National Laboratory, in partnership with the University of Tennessee at Knoxville and the Tennessee Department of Safety, conducted demonstration tests of vehicle immobilization technologies, or VITs, on February 27, 2007, at Michelin North America's Lawrence Proving Grounds in South Carolina. Vehicle immobilization technologies are classified into two main categories: vehicle disabling technologies, which impede the restarting of a vehicle once it is stopped or the engine is turned off, or prevent the starting of a vehicle by an unauthorized person, and vehicle shutdown technologies, which cause a vehicle to lose power as it is moving and eventually come to a stop. The Federal Motor Carrier Safety Administration identified 5 functional requirements of interest for vehicle immobilization technologies. They include vehicle disablement if a vehicle senses an unauthorized driver, vehicle disablement in the event of a loss of signal, remote vehicle shutdown by the driver, remote vehicle shutdown by the dispatcher, and remote vehicle shutdown by law enforcement.
This security platform consists of 4 individual modules that can function together or individually depending on the level of security that is required by either the transport company or its insurance requirement. Starting with the primary immobilization, we use the ULC S338-98 certified transponder-based passive proximity immobilizer that will only allow the vehicle to be started and driven by an authorized driver. We then add the driver authenticated idle protection system that will allow the vehicle to idle unattended and will shut down immediately if any unauthorized driver attempts to drive off with the vehicle. The third module is an anti-hijack system that is designed for driver safety and will bring a hijacked vehicle to a stationary position at a predetermined time frame, being either 1, 2, or 3 minutes. The fourth module is designed for the dispatch manager to prevent the vehicle from being started prior to its scheduled dispatch time. The technology is all transponder technology, which is a small little lobe like this which hangs on the key. This is programmed into the system and it's basically the driver's authentication. Without this, he won't be able to start the vehicle. It will shut down on several triggers, like a hood open push, a brake activation switch, in some cases RPM input, overspeed. If he puts it into reverse, the same thing will happen. If I give him this key back, he would be able to run the vehicle. Well, just first, I want to ask him if he can just shut it off. Here's the key, just put your foot on the brake. The hijack system will be enabled every time the ignition is turned on or the door is opened, or otherwise else configured, through pressure release valves, whatever the case. In that instance, each time the driver gets into the vehicle, he will cancel the override, the shutdown process. At that point, he can drive forever. The minute somebody opens the door, closes it on either side, it will trigger that shutdown process again. So in the event of a real hijack, somebody getting in there, putting a gun to his head, basically he's just going to say, take it, see you later. He's out the other end there. There's no keypads for him to panic over. He just has to hand the vehicle over to them and get going.
Test Track 8 at Michelin's Lawrence Proving Grounds was the site of the remote vehicle disablement tests. This 2-mile oval track covers flat terrain and includes a 560,000 square foot asphalt lake. A geofence was established along the entrance edge of the asphalt lake for these tests.
And now we have the first indication of a shutdown.
Device activated.
That is the second indication of a shutdown.
Say again. That was the second indication of a shutdown.
And now we have the third and final indication of a shutdown.
Vehicle is completely disabled but still controllable.
Is the engine off or on?
The engine is now in a
The engine is in a dying mode.
You see, I can't shift properly. I have no
Okay.
control over it. Shut down.
Now at this speed, it has shut down the engine.
Okay. Speed is,
5 miles,
yeah.
about 5 miles per hour.
The only way it'll roll as far as the weight is going to carry. What I'm going to do now is I'm going to come to a stop using my brakes.
So your brakes are still
Vehicle
dental brakes.
is braking and it comes to a stop.
Okay. Now to restart.
This VIT evaluation project builds on previous federal studies with a goal of developing best practices and a concept of operations for hazardous materials transportation and commercial vehicle safety and security. The best practice document focuses on motor carrier implementation of existing technology, while the concept of operations is a VIT template and protocols for law enforcement to use when interacting with a vehicle equipped with VIT technologies. Both of these documents are designed to enhance the safety and security of commercial motor vehicle and hazardous materials transportation from crime and terrorism.